Sure.
Well, welcome everybody. This is our second briefing for reviewers of the SDPi 1.0 specification, which is almost ready to go out for comment within the IHE devices group. These reviewing sessions, there's 4 of them in all, are really focused on giving reviewers sufficient background to be able to understand what it is you're looking at, and then be able to go through the parts that are of particular interest. So in the last one, it was kind of a general overview. What is it that is unique? What is it that's the same? How are all the different parts put together? And for example, most IHE supplements are for one profile. This one integrates 4 profiles all around the service-oriented device interoperability plug and trust profile. And so that was a general overview. We'll look at a little bit of that today. Today's, though, is really kind of going into more detail on the profiles. Like I said, there's 4 profiles. So that's what we'll spend today on. Just enough overview, hopefully, so that you can understand where the pieces are and how to navigate those. The next one is this Wednesday. It's focused on the gateways. So we kind of start with the gateway actor definitions in Volume 1, and then spend most of the time in Appendix B of Volume 2, where we define those gateways. A gateway between the SDC, service-oriented device connectivity ecosystem, and other ecosystems, primarily HL7 V2 messaging for the DEC and ACM profiles. So that's this Wednesday. Don't mention it. Don't miss it. And then we have a general question and answer session. Once you've gotten a chance over the holidays, when there's nothing else to do, and have questions or trying to grapple with stuff, we just have a general session on January 11th. So with that, this is a very quick recap of what we did last time. A lot of topics, and it's also recorded. By the way, I'll just show you where that recording is posted. Once I find it here, there it is, on our library page. So I will drop this into the chat. And but on this page, you'll notice towards the top, we have SDPi 1.0 reviewer sessions. So those sessions, we're going to record each one of these and post it on here. But this is the first time through. So even though we're looking at quite the daunting list, we learned a lot from last time. We plan on, after the review, devices internal review session, and before we publish this for public comment, we will re-record these with more of a focus on exactly what will be needed for those in the public reviews world to be able to understand what it is and use it. So these are a lot of topics. I also put the links into these. So when we post this later today, you'll see all of these links for specific pages and things that we went through last time. These are some slides now that are in there. We looked at this, the 4 profiles, and then the foundational, the gateways and the foundational standards that we use. We talked about the general organization of the technical framework. We looked through how all the different pieces map between themselves, both in Volume 1 and 2, as well as Volume 3. So all of that is in the first session, and now we're going to look at the second session. Let's talk specifically about profiles. So here are the topics that I hope to cover today. Number 1, a real focus on some of the unique challenges about a service-oriented architecture-based plug and trust protocol within IHE specifications. You have something that has a whole lot of interaction and is a very specific state model, but then you have a finite set of profiles and actors and transactions and content modules. How do we make those 2 work together? And so we'll talk about that because it's a little bit of a challenge. And then also we'll trace the flow from the use cases to profiles and transactions and content modules, enough for you to get a good feel for what we're looking at, how this hangs together, so that whenever you get the 1.0 version, you'll be able to look at it and keep your bearings. So with that, let's talk about these topics, especially plug and trust meets IHE technical framework elements and the challenges around that. And what we're going to do today is look at this rendering. So as we talked about last time, we write all of this in ASCII doc. We run it through an ASCII doc converter, publish it as HTML. So this is actually what you're going to see whenever you get the version to look at for review. Notice that last Wednesday when we had session 1, the IHE logo was not active on there. We had some bug. We fixed it. Thank you, David. Now it's showing up there. So this is what it looks like. And then also I will say that we have added to the very top these notes, okay? And this is a big note I added to the top that kind of gives you a lot of understanding about what is in this, what is still to be done. Notice in the yellow, I talk about to-do notes. Odds are, as you go through the 1.0 version, you're going to see some to-do notes. And we want specific comments on those, but it's work that we're going to continue doing during the review period and before we get to the public comment version. They should all be editorial or pretty simple. No great technical content there, but you'll see those. So this was added into the beginning there. We have 4 profiles, like I say, and in the top we talk about those 4 profiles. But let me drop down to this section, I think right down, is it 10? No, I think it's down here, to talk about the challenges of a SOA protocol right here. And so this is in the SDPi plug and trust profile. And notice this is a sequence diagram. And what you're going to see is, how did we address putting SOA kinds of interactions between these different systems in an SDPi IHE profile? And so this is an example that we have in there. We have 2 actors. I'll look at the actor models in a few minutes. And a provider, SOMS provider, that's a service-oriented medical device system provider, and a consumer system. And we look at how this works, a transaction exchange example. And so when you look at that, you see, well, there's announced network presence in an unsecured mode, or discover network topology. Maybe you're going out looking for something and you need to find a specific system. So there's an unsecured mode and a secured mode. We talk about that. And then you're going through this whole discovery process, okay? And then you manage it. And we use generally pub sub capabilities to manage a biceps subscription model, where we say, this is the stuff I want. And then you go into a loop where the provider systems send that out, information out to those who have subscribed to it. We also have a way of polling, again in the secured mode, but where you can go out and once you've discovered a system, you can go and poll and retrieve specific information from that system, specific kinds of information. And then of course, network departure. So this is a very high level sequence diagram that we provided. But note, whenever you go up here though, and look at the actor model, most IHE actor models have all sorts of transactions on them. You don't see those transactions. Here, instead, what you see are different actors, and we have some abstract aspects to these actors, which is the stereotype here, and some that are grouped this way here, and some that are foundational, but we don't have the specific transactions. Why is that, Todd? Well, that's because of the service-oriented plug and trust nature of this, we have a boatload of transactions, okay? So that sequence diagram kind of made it look nice and pretty, but then when you get into the details, you have a lot of transactions. Putting all of those transactions, as this table shows you here, onto that actor diagram, as you can imagine, would get really, really busy. You wouldn't be able to understand it. So that's one of the things that we've done here is we've tried to take this very rich messaging model for plug and trust interoperability, abstract it into some key big picture areas, into some big transactions. We've taken that out of the actual actor model for readability, but you'll see in some of the subsequent ones that we actually do have some of the profiles do have them right on there, like the SDPi reporting and alerting and external control. Okay, so that's just one of the examples we did. And that's how we're managing that. Okay, let's see, what's another topic here? So one of the key things we have that is unique, as I said last time, is a way of looking at use cases that are not all buried within a single profile. Because like I said, we have multiple profiles, 4 of them in this supplement. Each profile has a use cases section. So for SDPi, we have this use cases section right here. And it needs a lot more added to it. Actually, I thought I added that in there. Oh, it hasn't been pushed to the main yet. So we'll actually have in this use case here, oh, I do have it here. We have a link back to synchronized time across devices. So from the use cases, or from the profiles, the use case section, they point back to that general appendice where we have all of these in Appendix B, or C, I'm sorry, within Volume 1, where we have all of these use cases. And so what I would like to do, and the use cases, by the way, might be implemented, the requirements supplied by multiple different profiles in those profile-specific use case sections. But we put them here in a profile or in a technology agnostic way to just capture what is that clinical profile that we're looking at. So what I want to do right now is just let Ken Fuchs give you a little bit of a tour of these here, and we can understand what are the 1.0 use cases that we put in Volume 1, Appendix C. So Ken?
Sure. Well, we have, I don't remember now, we have maybe around 6 use cases that are relevant for SDPi 1.0. There are also some use cases listed that may be a little bit more forward-looking. As you've already discussed, this first use case is, for most people, they would relate to the continuous time, consistent time IHE profile. So this is kind of similar. What we don't say, for example, here is we're have a non-specific time source. So it could be NTP, or it could be some other time source that's driven more through the SDC protocol. And what we have is we show a number of a quick narrative that basically we have a medical device that gets attached to a network and it somehow gets the correct time. And we have technical preconditions that are written in some sort of a gherkin-like syntax, and we have then a number of scenarios. The first scenario usually is the happy path, and in this case, basically, we have the device connected. It detects a time service of some sort, and it synchronizes its time. And then the second scenario, for example, is a little bit, it's a normal situation where the time at another device is changed manually, and we continue to synchronize with the time service. Or the device is connected but can't find a time service. Well, what should it do? In this case, we say it's out of scope. So this is where we have a scenario for a future SDPi version. Similarly, the fourth scenario, 1.4, it's connected to a network but can't connect to a time source server, and another device's time setting is changed manually. What do we do? Again, that'll be considered for the future. We can then move on to use case 2, where we basically have a single patient dashboard. And the dashboard is something that will display the real-time information from various beds. It can display alarms, but doesn't sound those alerts, and it doesn't provide any remote control or external control capabilities. So it's kind of a passive display only situation, which could be used in a number of different types of clinical situations. You can see the dashboard there that connects to a monitor, pump, and ventilator, or some other number of devices. And again, all these devices are on the medical device LAN. We have one ICU dashboard display, and the devices have already been assigned. So that's the technical precondition. And then we have a number of scenarios similar, where the first scenario is again, the happy path. We have basically the devices are connected to the dashboard, and it's displaying all the information from those accessible devices. But then we have the other scenarios where maybe a device is inaccessible. It was configured, but it can't detect it. And what should we do? Or a device that was accessible goes away. Those are the two scenarios that we have identified for this use case. We can then extend that use case. So these use cases try to build on each other. In this case, we have a dashboard that has more than one ICU that it's monitoring. Similar preconditions, and we all, I didn't mention, but each one of these has a narrative that kind of expands on the use case itself, or explains the use case in a clinical context, but we don't get too clinically into the weeds here. It's very high level. And we have, again, the scenarios where we have the happy path, where everybody's fat, dumb, and happy and communicating with the dashboard. And then we have scenarios where, again, devices either are inaccessible or they go away. The fifth use case kind of engages a gateway kind of situation, where we have devices again on the medical device LAN. In our case, it would be an SDC kind of LAN, and they're communicating with a data gateway service, which in turn communicates with an enterprise system. And we have basically the happy path, where we have the gateway service has detected a new in-scope device, and it will connect to that device and export that data to the EHR. I don't know if we, looking at it, I'm not sure we need to get specific about what I think in this case, yeah, we're talking about using IHE-dev DOR and DEC profile. We connect the second scenario connects the data gateway service to the EHR. And then we have a number of failures in scenarios 3 and 4, where either the service has a failure, and then how do we deal with that when we talk about backfilling, or the gateway service to the enterprise system fails. And again, we talk about having the gateway service backfill to the enterprise system. And we have the fifth use case, which is now similar to the gateway service, the data gateway service. We have an alert gateway service, and that's communicating with some sort of clinician notification system, which in turn could be communicating with pagers or smartphones or some other mechanism of alerting the nurse directly. And again, we have all these devices on the LAN. We have at least one alert gateway, and it's connected up to and all the devices on the LAN are connected to that alert gateway, and it in turn is connected to that clinician notification system. There's kind of an assumption here that the devices, or at least the alert gateway, has some way of identifying the device label or location or patient ID, so that when the data gets to that notification device, the user knows who it's or what location it's reporting on. So yeah, we have again, a gateway service. It's detected a new device, and it will start communicating that to the clinician notification system. However, we have again bad scenarios where it's either the gateway is losing connectivity with the ICU devices, or the gateway service fails, or the clinician notification system somehow loses connectivity. It may go down, we don't know. So we have different scenarios that we have to handle. And I think finally, the current use case 6 has to do with communicating to an alert recording system. So we have a slight different situation here, where it's very similar to the notification approach, except here, if something goes, if there's a failure, we try to backfill. So in the real-time clinician notification scenarios, which is use case 5, we don't worry about backfilling. Here we try to backfill into the alert recording system.
Excellent. Thank you very, very much, Ken.
No problem.
And these are, as Ken said, the first 6 for 1.0. As we get into these for 1.1, SDPi 1.2, 2.0 into the future, we will both add content and detail into these and add some additional ones. We have a set of additional ones out there, but they will all have the same general organization. And so let me find my cursor here. There it is. This organization of where we have a use case feature, this general narrative, maybe a technical view to help people understand in a generic sense, what kinds of systems and devices are you talking about, preconditions, using this Gherkin kind of language, which is very easily readable, but it also has enough structure that you can map it well to specific technical implementations, and then the scenarios. And during the review, I would ask those who are looking at these to say, you really should add this scenario to it, or this and condition should be added, or so look through that and things that make sense or don't make sense. Yeah, you forgot one or something like that. Please put that in the comments for this SDPi 1.0 so that we can get it included. And then notice also, I'll just go up here to one of these. Yeah, notice that we have links, as you saw last time, to specific content. So for example, things that are alert related, you might have this whole concept of an alert distribution information system, or distributed alert system, or a confirmed distributed alert system. We actually have a section that was crafted that has those definitions in here. So you can link to that when you're saying, well, what exactly was that? And how does that relate back to this ISO IEC 60601-1-8 alarm standard? So that kind of gives you an analysis and update of that. And then also you saw these highlighted ones in here. So like, for example, we have this just generic medical device LAN. And if you click on that, remember, that takes you back to our glossary, our all-inclusive glossary, and it kind of gives you a simple definition of what we're talking about, and then links to some other ones, okay? And so, and an SDC LAN is maybe an alternative acronym for doing that. So that's all integrated here. But as Ken was going through that, I'm sure you could see how these different use cases might map to different profiles. So if I go back up to the top and look at this diagram, which is in the supplement, okay? We have these 4 profiles, but as you looked at the data, all of them use connectivity, right? That's the bottom line, is you have to be able to plug in and trust connectivity from device to device. That's kind of like the baseline here. But a dashboard, well, that really is focused on reporting and of medical data, not just maybe generic health information, but medical data. The alert ones may include that, but they also include this alerting profile. So the requirements from those would map more to the alerting profile. And we don't have a lot for external control in this first 1.0 version, but maybe you kind of get a sense from what Ken talked us through, how those generalized use case scenarios and logic would map to multiple profiles. And that is what the effort is now in the profile specific use case sections to identify what requirements from the general use cases that each profile supports and where, so you can kind of drill down on that. Okay, so let's take a look again where we're at. So we've talked about the whole challenge around a SOA plug and play, plug and trust architecture in IHE stuff, right? And the managing between the actor diagrams in a boatload of transactions, some that are abstract. When you get into volume 2, you see those transactions, but then appendix B for the actual messaging sequence, it gets into the nitty-gritty detail down there. We talked about use cases from very general to profile specific and some of the challenges around that. So let's look now just at the actor models and transactions and some specific areas around this, including grouped actors, which is a key thing that we're doing in this 1.0. So if I go back here and I go back to our SDPi actor diagram, sorry, that was up, I'll go up here. Notice that we have a very simple core actors here, and then we have this optional set of connector actors. Again, all of the actors everywhere are SOM's participant. It's like every system has this baseline set of capabilities it must support to be able to interplay with the other devices and systems around the network. But this is a specific kind of actor here, a set, which is a SOM service-oriented medical device system connector between this SDC, SDPi world on the left and other systems that aren't that on the right. And we've identified, and so this connector has, on this side here, a specific API. You're like, so why is that? Well, this here is actually an incoming. I could actually put an arrow on there that might help. So whereas this is bidirectional here, this is incoming to where the information from a provider system might come into a connector, a generic API, and then depending on the kind of ecosystem on the right, it would then be converted into that messaging there in these gateways. But maybe it's coming from the other direction, right? And so it might come from some other system, for example, patient demographic information that would come into a consumer. And so this API for this connector would say, here are the kinds of gateways and service sources, the kinds of things that we provide that are connected to the external world, if you will. And then this consumer could actually connect to those gateways with that general API. So it's a standardized API with SDC on one side, SDPi on the left side, and then unique connections on the right side. For this version 1.0, we're really focused on the V2 gateway because, as you'll see, we have grouped actors in the other profiles for reporting and using HL7 version 2 based messaging profiles. So that's the one that'll be in 1.0. However, we also are anticipating in 2023 adding a fire gateway, perhaps for doing a query for a patient demographics query or something like that. So this would be the foundational, how do you map SDC to fire constructs? And that's the work that John Rhodes in the HL7 Devices on Fire group is pursuing right now. And then in the future, we might have a sensor gateway, sensors being data sources, maybe actuator gateways sometime too, that do not, are so simple they cannot support an entire interface, an interoperable interface for SDC or SDPi. But you might have a gateway where the sensors would connect into that and then make that information available to other systems here. So this one up here might be invoking a gateway here, or you might have basically an actuator gateway, and then you might also have sensor data here. And then a smart app platform, an app that would plug into a platform. The apps themselves might be external to it, but it wants to leverage SDC-based data. And so this platform would provide an API on this side for plugging into it, and then it would handle all of the nitty-gritty of what devices are on, are plugged in, and what kind of services are available. So these are all ones that we've identified. They'll be detailed, at least in described in what you just heard, but the specific one to pay attention to is this V2 gateway. So that is a very quick tour of that. And then, like I said, for each one of those abstract transactions that you saw, for example, announced network presence in that sequence diagram at the top of this, you'll see that here. This will link then to that section, to that transaction, and then notice here. So if I click on that, I end up over in volume 2, and this is the specific transactions there. And so there's a link from that table into the volume 2 directly. And I think David gave us a tour of these and how the content of these relates to Appendix B of volume 2, or Appendix A of volume 2, where we have all of the detailed messaging there. And so that's the linkages that we provide there. Let's see, the other thing that's unique here is that you'll see these here. You'll see that we have defined a biceps content creator and consumer and provide content. What this cloud means is that we're not really focused on the specific transactions and ways in which the information is exchanged. We're more focused on the content modules that are provided. And so in volume 3, we have generic SDC biceps content module definitions, and then we have specific ones for infusion pumps, ventilators, physiologic monitors, surgery devices. And so why do you provide this? We are doing that in SDPi 1.0, and we'll expand it in subsequent versions as a way of focusing and tying in the content from volume 3 to specific profiles in volume 1. And that means that whenever I do testing and I actually have a system implementation conformance statement that I do for a system saying this is what it supports, I'm not only going to say that it supports SDPi P, maybe SDPi R for reporting, but I can say that it actually supports the infusion pump content module right here, and it can be called out. So whenever you see that system declaration in an IHE declaration of conformity, you will be able to see that content module. Okay, so we added that in. It's a little bit new. It's not new to IHE, but for the devices, it's a little bit new. Let's see. Let me very quickly then take you just to show you the other actor diagrams. So as I said, this is the one for reporting. This is interesting because now you'll see this grouped actor. What is the grouped actor? So it's where you see two actors with a little line in between it. That line means that this SOMS medical device consumer or provider, which is unique to this profile, leverages or groups and inherits the capabilities provided by this SOMS consumer and SOMS provider system in the SDPi profile. What do you mean you inherit it? Well, this data consumer provider, how does it plug and trust? How does it discover? How does it go through all of that? All of that is bundled here in this area here. The difference is that these are really focused now on the exchange of medical device data. And so, whereas you saw in the consumer and the provider that SDPi is supports fully the exchange of health information, if you will, between these systems, and it can be medical device data, medical data. It could be just general information. This here is very specifically medical device data. And notice that we have the same kind of connectors and gateways. And here we're using, we have both the SOMS Fire as well as the SOMS V2. Now in 1.0, we won't go into detail on the Fire, but we will on the V2. So this is where we group that gateway, and the generic SDC to HL7 V2 messaging mapping is covered in this generic gateway part of it from the SDPi, but this adds the requirements for the DEC gateway, the device to enterprise communication profile. And then you can see the different transactions that are specific to that profile on the right and how that maps into the transactions here. On Wednesday, we'll go into detail that. Peter who has written those gateways, the SOMS DEC gateway and the ACM gateway, we'll look at that in a moment. We'll look at the details of that mapping, but you can see how those are grouped and inherit from the generic ones from the SDPi for that gateway or connector, and then how we do the same here. The actual transactions themselves are also mapped. And so when you look under the hood, when you go to Dev 36 in Volume 2, you'll see, well, it's mostly the same kind of transaction from the inherited SOMS consumer for publishing data. However, it has additional constraints that are specifically for the medical data. Where do those constraints come from? Well, one of those sources of that, and I'm going to pop back up to this model very quickly here. A source of those, so now we're talking about reporting here, is from this participant key purposes standards, which say to be able to do reporting of medical device metric information in a safe way that's also secure. There's a standard. It was just approved a few weeks ago, SDC 11073-10701. And so the requirements from that standard will generally map onto this SDPi reporting. So even though the technical, how do you exchange information, might be mostly all covered by the foundational SDPi via that grouping, actor grouping approach, the additional requirements from this that anybody implementing that would have to implement and support is provided by these standards here. And we will add that into SDPi 1.1, for example, the explicit mapping of those requirements. But that's one of the reasons why we broke these out. And while I'm at it, it's the same for SDPi alerting, where there's a standard we're working on. Hopefully we finish it in 23 for 11073-10702 for alerting, alert information in a safe and secure way. And there's also one for external control. So that kind of gives you a sense of what you're going to see in the SDPi R transaction model, okay? And the detail in this section will be the same as the others, where it'll link all the pieces together with the use cases to this one here, and then to the transactions and the content modules. Very quickly, let's just look at this. Similarly, we have the same kind of grouped actors with the SOMS consumer and provider for basic plug and trust connectivity, but this one is looking at a specific kind of information. And also are some specific SDC transactions and messaging and service models that are support alerting and alarm communication. So that is what you'll see here. And then we have this ACM gateway to the ACM profile. And that leverages, again, that same SOMS v2 gateway. And part of this gateway, which we'll look at on Wednesday, says, okay, this is what it looks like on the SDC side, SDPi side. This is how that maps into Dev ACM. For 1.0, we are only supporting Dev 04 outgoing, not incoming, and not the confirmation 05. We'll do that later in 2023. And so this section here will go into the details of that, and obviously also map in the requirements from those use cases that Ken went over that are specific to alert and alert kinds of systems. Now, just for a matter of completeness, here I have added a very simple external control model. This is totally out of scope for 1.0. We'll probably get a little bit of this in 2023 in a subsequent version, but you can see it follows the same pattern as the other three profiles right here. But notice I also add this note. You'll see a lot of these notes, like I said, throughout here, indicating that, oh, by the way, external control is generally out of scope for 1.0. And then I have a point to the SDPi version article where we said, well, what are we doing in 1.0? What might we do in 1.1, etc. So you can go see that. And so I give you a heads up. So as a reviewer, you'll understand that. And yeah, so let's see. I think that's it for the general overview of that stuff. We talked about that. We talked a little bit about volume 3 linkages and content actors also. And then I think what I'll do right now is just go into this SDPi 1.0 and beyond. So like I said, if you click on these kinds of notes here, it's going to bring up this review table. So this is on the wiki. I will give you, I'll post that here to the chat, so you have that link, and it'll be in the notes here. But this is the wiki article. This is what we're working on right now, just a baseline document, and having that ready for review pretty soon, in a few days actually. These are the really high-level capabilities. Notice we have TBDs for the 1.1, 2.0 next year, and we have ideas. Come January, we'll start working on what does that detail look like for each of those. But if you go down to the detail section, this is all the kinds of things that we anticipate having in here, both in terms of use case scope and as well as technical scope. There will be options, there will be additional things that we add in later on. But this is what we're doing now, and we even have some initial 1.1 ideas there. As I said, the base PKP, metric PKP in here, and maybe have some additional conformance content and logic in there for the base standards, as well as these two PKPs. So that's what we're looking at for the for this 1.0 version. So to summarize, and sorry for going through this so fast and so quickly, but hopefully you got an idea of how we're doing the profiles, some of the challenges and how we're addressing them that may make them look a little bit different from what you've seen in other IHE devices profiles, as well as other profiles elsewhere in other domains within IHE. And the reason for that, we think that it hits a pretty good level of detail and abstraction, and using the conventions that we have in IHE technical frameworks to be able to make it manageable and understandable. But as reviewers, you can be the determinants of that. And we look forward to your looking through these, identifying especially the things that need more detail, the things that don't make sense, and corrections, things that we need to add, even links that are broken. We're going to go through and try to get all of those done, but I'm sure there will be links that need to be added and that may be broken. So with that, I will pause finally, take a breath, and ask you if you have any questions at all based on this general overview for the profiles. All right. Well, thank you very much. And this will be posted, as I said, later today. And we look forward to your being able to dig into this and give us some good feedback. Like I said, our next session is this Wednesday at 6 o'clock, America's finest city, San Diego time, and 3 o'clock in Central Europe. And that specifically will give you an overview of those gateway actors. And then Peter is going to take us through a detailed overview into DEC and ACM, so you can really look at how does that mapping and gateway part work. These are all the topics that we will address on that. And then after the holidays, after the new year, we will have this final general Q&A session, the 11th of January. And we're looking forward to being able to answer your questions then. So with that, hope to see you all on this Wednesday.